Yeah, welcome to this video. Our objective is that we'll be able to take linear tables and turn them into equations. Let's just dive right in here. I'm going to hit a bunch of points. The first one might not make a ton of sense. I'm just going to tell you the first one is linear, and then we'll kind of dive into y in a second. But with a linear equation, we always use y equals mx plus b. We have to remember the parts here. B is the beginning or the y-intercept, and m is the constant rate of change or slope. And so um, if we want to make an equation for this line, we need both these parts. We need to find the slope and the y-intercept. So I'm going to say m equals and b equals and kind of search for these. Actually, let me give myself some more space. Okay, so m, or the slope, or the constant rate of change, is equal to the change in y over the change in x. Okay, and it's only linear if these things are changing at a constant rate, so the same amount each time. So from 4 to 8, we're changing by 4, right? From 8 to 12, we're changing by 4. From 12 to 16, we're changing by 4. So the change in y here is 4. All right. And now I'm going to look at x. We're clearly counting by 2s, right? So this is changing by 2. The delta x is 2. And so we get 4 over 2 as our slope. That simplifies because this is just a division line. So 4 divided by 2 is 2. And so the slope, or rate of change, of this table is 2. Now, to find the y-intercept, b, the y-intercept is the value of y when x is 0. So when x is 0, what is the value of y? Here it's 4. And so we get b equals 4 and m equals 2. And now we can just write an equation. Y equals 2x plus 4. All right, I just plugged in my m and b. And here we go. This equation and this table actually show the exact same relationship. All right. If you plug any of these points into this equation, you're going to get something that's true. So these are the same thing, just shown in a different form. All right, your turn. Go ahead and try that you do. Create an equation that represents the table below. We have a table. This is where the learning happens, so please go ahead and pause and solve. Okay, hopefully you're unpausing because you solved on your own. That's the most important part. I say it in every video, but that's where the learning happens. Just writing down what I write down. There's no way to learn. So we have a linear equation, y equals mx plus b. To find the equation for this, we need to find m, which is the change in y over the change in x, and b, which is the y-intercept. Here I can see we're going up by 1 each time on the y, and we're on the x, it looks like we're counting by 5s. So we get 1 over 5, which I had students when I taught this lesson calling this 5. This is not 5. This is 1 divided by 5. Right? If I have one candy bar and I divide it amongst 5 people, you're all going to get 1/5 of a candy bar. You're not going to get 5 candy bars. So this is 1/5 and it stays 1/5. So we get 1/5 here. As the m, we need the b, the y-intercept, which is the 0, right? When x is 0, what is y? Well, when x is 0, y is 2 here. So b is 2. And so now that I know the slope and I know the y-intercept, I can simply just plug into y equals mx plus b. I'll write my final answer here in pink. I get y equals 1/5 x plus 2. This is the equation that matches this table. All right, example 2. Create an equation that represents the table. It's the same thing, but it is a little bit different, so please don't rush ahead. There is an additional skill that we need here. First, I'm going to check to make sure it's linear, right? Is this a constant rate of change? Yes. So is this. All right, so it is linear. And I can use y equals mx plus b. And we plug in, right? Plug into, we need to find m, and which is the change in y over the change in x. And we need to find b. How much is y changing by each time? 4. How much is x changing by each time? 1. 4 over 1 is 4. So the slope or rate of change here is 4. And b, remember, b is the value of x, or value of y when x is 0. I don't have the x is 0 here. So I'm going to actually extend this table in the wrong direction, and see what I can do. So here's 4. I'm just going to count until I get to 0. 3, 2, 1, 0. And now I'm going to count y back by an equal amount. If this is going up by 4s, to work backwards, I got to go back by 4. So this is 8. Go backwards 4, I'm at 4. If I'm at 4 and I go backwards 4, I'm at 0. Backwards 4, I'm at -4. And then I'm at -8. So the value of y when x is 0 is -8. So b is -8 here. And so now I know my two parts. The slope of the equation is 4. The y-intercept is -8. I'll write my answer in red here. And the answer is y equals 4x minus 8. This equation and this table show the same thing, show the same relationship, in different forms. All right. Here's the you-do. Go ahead and pause and solve. Do the best you can, and then we'll go over it. All right, hopefully you just solved it on your own, and so I can go over it pretty quickly. Hopefully you recognize this as a linear equation because it has a constant rate of change. Obviously, they're all kind of linear at this point in the game. We will learn about some other type of functions, so be ready for that. We need to find the slope, which is the change in y over the change in x. And we need to find b, right? So how much is y changing by each time? Hopefully you got this here. This time it's changing by -6. It's going down 6. I'm going to use a -6. X is changing by 3. We get -6 over 3. Remember, this is just division. -6 divided by 3 is -2. So m is -2. To find b, I'm going to need to extend this table up. Here I'm counting backwards by 3. So, or I'm counting up by 3. So I'll go backwards by 3. And look, x is 0. That's what I want. What is the value of y when x is 0? Well, if this is counting down by 6 in this direction, we got to count by up by 6. So if I'm at 38 and I go up 6, now I'm at 44. And so the value of b is 44, right? And so now I plug these into y equals mx plus b. I get y equals -2x plus 44. And this are the same. They're the same thing shown in different forms. All right, last one, we're going to kind of apply this to a real world example. I have example 3 here. Let's dive in. The table below represents a relationship between the height of a plant in inches h and the amount of days since planted D. Use the data to create an equation that models the relationship. All right, so let's create a model here. It looks to be linear. These are moving constant rate, constant rate. All right, y equals mx plus b. All right, let's see what I got here. I need to find m, change in y, over the change in x. How much is y changing each time? Looks like 2. X is changing by 1, so the slope is 2. Now I need to find b. Gonna need to extend this table upwards. So I have a 2 here, 1, a 0. Count this way, we're going up by 2, so this way we got to go back by 2. 10, 8, 6. B is equal to 6. I don't want to just use y equals 2x plus 6 here. I want to use the variables that make sense. In the y column, I have height. So I'm going to say h is equal to 2. And instead of x, I'm going to use d for days, plus 6. All right, so use the variables that make sense. Don't just write y equals 2x plus 6. Use height and days so we can really describe what's going on here, okay? All right, last one. Last you do. Go ahead and hop on this on your own. Pause when you're ready for me to go over it. All right, the table below represents the relationship between the profit P for a company and the amount of units sold U. Use the data to create an equation that models the relationship. I'm going to go speed, y equals mx plus b, because this is linear. They're changing at a constant rate. M is equal to the change in y over the change in x. Y is changing by 10 each time here. X is changing by 2. 10 divided by 2 is 5. We got to count backwards to get the y-intercept. So this is going to be 8, 6, 4, 2, 0. And now I got to count these backwards by 10. I'm at 4 and I go backwards 10. I'm at negative 6, negative 16, negative 26, negative 36, and negative 46. And so B is negative 46. And instead of just generic plugging in y on x, I want to make the profit function, right? In the y column, I have P equals 5U for units sold minus 46. There's a story to be told here, right? This is a linear relationship. They start $46 in debt because it's a negative 46. They make $5 per unit sold. So that's the story that goes with this equation. And that's the story that goes with this table. We could also make a graph. But either way, we're just showing a linear relationship. All right, y'all. That's it for this video. As always, ask your teacher if you need additional assistance.